Hi everyone, welcome back to the coding series. In today's video, we will be solving today's LeetCode problem. Determine whether matrix can be obtained by rotation. Let's understand the problem statement. Given two n cross n binary matrices, mat and target, return true if it is possible to make mat equal to target by rotating mat in 90-degree increments. Let's understand that with the example. Okay, given matrix is this one. If you rotate this matrix by 90 degrees, that looks similar to this. Okay. Now let's compare these two. Here, elements in the column 0 are in row 0 but in the reverse direction. So 0, 1 in the column 0. If you reverse that 1, 0, see 1, 0. Similarly, elements in the column 1 are in row 1 but in the reverse direction. 1, 0 when you reverse that 0, 1. Okay. Now you have to check whether this resultant matrix is equal to target or not. If it is equal, you have to return true. If it is not, you have to return false. In the second example, given matrix is this one. Okay, if you rotate this matrix to any of 90 degrees, none of the matrix will look like target. Okay, so you can check that. So that will be false. In the third example, if you rotate this matrix by 90 degrees, that looks similar to this. If you rotate this again by 90, that looks this one. Okay, now check whether this matrix is equal to target or not. Okay, if it is equal, then you have to return true. Okay, now check. This is not equal to target, but this is equal to target. So output is true. Now let's see how we can solve this problem. So given matrix, or let's consider this matrix. Okay, let's consider 1, 2, 3, 4. Okay, if you rotate this by 90 degrees, that looks 3, 1, 4, 2 because elements in the column 0 are in row 0 but in reverse direction. If you rotate this again by 90, that looks 4, 3, 2, 1. Again by 90 degrees. So 2, 4, again 1, 3. Okay, rotate again this by 90. 1, 2, 3, 4. Okay. If you rotate this matrix by 180 degrees, that looks like this. 270, 180 plus 90, this one. 360 is this one. That see, if you see this and this are same. Okay. Now we have target. Okay. Now you have to check whether either one of these matrix is equal to target or not. Okay. If it is equal, then you have to return true. Okay. Now let's consider 1, 2, 3, 4, the same example. If you rotate this by 90, 3, 1, 4, 2, right? Let's see the indexes 0, 1, 1, 0, 1, 1. Here 0, 0, 0, 1, 1, 0, and then 1, 1. If you see here element 1 in this matrix, that is at 0, 0, is at in the position 0, 1 of this matrix. Okay, so 0, 0, 0, 1. Similarly, two element in matrix, given matrix, is at position 0, 1, but here it is at 1, 1. So 0, 1, 1, 1. Okay. Now 1, 0. Element 1, element 3 here moves to here. So 0, 0. 1, 1 moves to 1, 0. Let's take this matrix 1. Okay. Now, so elements at matrix of I, j is moved to which matrix index at matrix of 1. You have to check that. Okay. Now see. Can I write I comma j elements at I comma j move to elements at matrix of j n minus 1 minus j minus I. Okay. Now let's see that. J moves to n minus 1 minus I. Here, using this, you have to achieve this because element 1 at 0, 0 is at position 0, 1. Okay. Now 0, 0. Here j is 0. N is equals to here 2 cross 2 matrix. Okay. That means 2 rows. So n equal to 2. So 2 minus 1 minus I is 0, right? So 0 comma 1. See, 0 0 we have achieved 0 1 using this. Similarly 0 1 you see 0 comma sorry this is j, that is 1. Now 2 minus 1 minus 0, that will be 1 comma 1. See 0 1 1 comma 1 0 1 1 comma 1. Similarly 1 comma 0 0 comma 2 minus 1 minus 1, that will be 0 comma 0. 1 comma 1 is also 1. 2 minus 1 minus 1, that will be 1 comma 0. 1 comma 1 we have achieved 1 comma 0. See 1 0 1 0 0 0 0 0. Okay. Now, okay, using that matrix of I comma j elements which are present in matrix is equals to matrix 1 of j comma n minus 1 minus I, because using that we have achieved this, right? So I can write this. Okay. Now now this matrix you have rotated by 90. Now rotate this by 90. Okay. So when you rotate that by 90, 4, 3, and then 2, 1, right? 4, 3, 2, 1. Okay. Now you have to see here matrix of matrix. This is matrix 1 and this is, let's take this as matrix 2. Okay. Matrix 1, you have to check whether like this element that is present in this index, some index, is moved to which index of this one. Okay, you have to check that. Now matrix 1 of j of n minus 1 minus I moves to which index? See, okay, if you see here I comma j, you have kept as j comma n minus 1 minus I. So okay, that means j comma n minus 1 minus I. Similarly, can we derive using this equation? Can we derive this? J comma n minus 1 minus I. Let's take this as I using like this. Okay. Compare this with I, compare this with J. Okay. Now see, J moves to J. That means J is this one. N minus 1 minus I, comma. Here, this is J. So we have written. Now, this is I. Here, I how we have written like this. So, N minus 1. So, that will be J. Okay. You can check that. That means elements that are present in matrix 1 of this at j comma n minus 1 minus I is equal to matrix of okay n minus 1 minus I of n minus 1 minus j. Okay, that means, okay, here this is our original matrix 1, 2, 3, 4. If you rotated this by 90, you got this one. Okay, that means 90. If you rotate this only by 180, that looks like this, same as this one, 4, 3, 2, 1. So can I write, see, matrix of I comma j, okay, when you rotate it, you got these elements at I comma j moved to here. Okay, now when you rotated this is 90, it moved. So can I write matrix of I comma j, elements at matrix of I comma j equal to matrix, because this is matrix 2, this one. Okay, matrix 2 of n minus 1 minus I, n minus 1 minus j. Okay, so this is for 180 and this is for 90. Okay, now you have to derive it for, see, if you rotate this by 90 degrees, that will be 2413, right? 2413. Okay, now that means this 270, right? If you rotate this matrix by 270, that is this one, nothing but if you rotate this matrix by 90, that will be this one. Okay, now you have to derive it for 270 as well. Okay, now if you rotate this matrix, that means this indexes you can write. Okay, n minus 1 minus j, sorry, minus I, comma n minus 1 minus j, using that same derive this. Okay, you take this as I, this as j, so that will be n minus 1 minus j of n minus 1 to n minus 1 minus I, because you have written like that only, right? I, here I. Similarly, here I is pointing to n minus 1 minus I. That means this will be cancelled. That will be only I. So n minus 1 minus j. Okay. So can I write matrix of I comma j? Okay, if you rotate it by this original matrix by 270, so matrix of n minus 1 minus j of I. Okay, this is for 270. This will be some matrix 3 you can take. Okay, this is for 270. Now you have to see here, as I mentioned, we have one target. Okay, we don't know whether target can be this or this or this or this, or it might not be. Okay, now you have to check if it is equal with any of these, then you have to return true. Okay, now let's code that. Let's take matrix 0, matrix 90, because 0 90 means matrix 0 degrees, matrix 90 degrees, just for pointers. It is referring some pointers. 180, and then matrix 270 equal to, you can initialize that with true initially. That means either target can be any one of these. Okay, sorry, Now n is equals to ln of mat. Now iterate for I equal to 0, I less than n, I plus plus, and you have to iterate every elements in a row. So j less than n, j plus plus. Now if mat of I comma j equal to, so if it is not equal to target of I comma j, because if you rotate this mat by 0 degrees, that will be as it is. That even what if our target is that? So to check that, we are writing this. Okay. So if it is not, you can just assign our matrix pointer to false, and so for the first time it will enter here. Okay. So now if it is false, then you no need to check again the next condition if it is false. Now similarly check for 90, 180. I will edit this 270. This as 90, 180, 270. Similarly 90, 180, and then 270. Okay. Now here using these formulas, if you see here, this one, matrix of I comma j. Matrix 1, this can be a target or not, we don't know. So that's why we have to check. Okay, target here, if you rotate it by 90, so that will be j of n minus 1 minus I. J of n minus 1 minus I. Similarly here, when you rotate it by 180, n minus 1 minus I, n minus 1 minus j. So n minus 1 minus I, n minus 1 minus j. Okay. And here this one, first n minus 1 minus j of I, n minus 1 minus j of I. Okay. Now, sorry, this is 270. After that, what you can do, you can just return, sorry, this should be here, return matrix of 0, okay. Now here also OR condition, but this will be 90, 180, and then 270. Okay, because you are keeping these pointers to check whether given target is equals to matrix 90 or not. Like whenever you rotate our matrix by 90 degrees, if that is equal to target or not. If all these are false, means our given target is not present in that rotated matrices. Okay, so let's see that. matrix 2 matrix 0. Okay, this is matrix. Let's submit. See, 3 passes. Let's submit this. We'll see whether all test cases are passed or not. All test cases are passed. If you think about time complexity, for every row we are iterating through n elements. So for n rows, n elements, that will be O of n square. For space complexity, we are taking 4 pointers. Okay, that will be, since these are constant, that will be O of 1. Okay, so m complexity is O of n square, space complexity is O of 1. Okay, that's all for today. If you guys have any questions, please do add in the comment section. Like and subscribe for more videos. Thank you.